Okay, we have these two ways of combining statements called a conditional and a biconditional. Bi means two. We expect that the biconditional is somehow two conditionals. Let's look at the ways that we have of phrasing conditionals and see what we can make of this. The biconditional, if we have the simple statements, Kyle will go for a walk every day, and Kyle has a dog, the biconditional form of those two statements is, Kyle will go for a walk every day, if and only if he has a dog. But wait a minute. We can write a conditional using only if to introduce the then part. Right? We can write, Kyle will go for a walk every day as the if part, and then we say, only if, and then our then part, our consequent, is he has a dog. That's one of our ways of phrasing. If Kyle goes for a walk every day, then he has a dog. Kyle will go for a walk every day only if he has a dog. We could also say the if part second, as long as we introduce it with if. We could also say, Kyle will go for a walk every day. That's our then part. If he has a dog. That's our if part. We introduced it with the word if. Do you notice that these three sentences are very similar? Here we have only if. Here we have if. Put those together with an and between them, and we get if and only if. The biconditional is just two conditionals combined with an and. Coincidence? No, of course not. Anytime we have a biconditional, that is equivalent to the two possible orders of conditionals with those two simple statements combined by an and. Okay, so that makes sense on the level of the words. We probably wouldn't say it that way if that wasn't so. But on the other hand, we have these two conditionals that are not symmetric. We combine them with an and, which is symmetric, and we get something that's symmetric. That might be a little bit surprising. Let's see how that works out in the truth table. So, for P, if and only if Q, remember that's true when the two have the same truth value. It's false when they're different. So true if and only if true, that's true. True if and only if false, those are different, so that's false. False if and only if true, those are different, so that's false. False if and only if false, those are the same, so that's true again. Okay, so for if P then Q, well, P is the antecedent, Q is the consequent. That's going to be false when P is true, but Q is false. And it's going to be true the rest of the time. If Q then P, well, Q is the antecedent and P is the consequent. So that's going to be false when Q is true, but P is false, and true the rest of the time. And then we want to do and to these two statements. So, and is true when both are true. It's false when at least one is false. So true and true, that's true. False and true, That's false, because one of those is false. True and false, again, one of those is false, so that's false. True and true, those are both true, so that's true. And we see that that actually did work. Our if and only if column and our column for anding the two conditionals together, those really, really are equivalent. And again, that equivalence has a name. It's called biconditional exchange. We're exchanging our biconditional for the two conditionals, or exchanging our two conditionals for the biconditional.